So in this third part of the presentation on hypothesis testing, we're going to look at this thing called a p-value. The p-value is the probability computed using the test statistic that measures the support or lack of support provided by a sample for the null hypothesis. An important thing to note here is the idea of a test statistic. So the test statistic is a very important part of hypothesis testing. If the p-value is less than or equal to the significance level alpha, which is this down here, if p-value is less than or equal to alpha, the value of the test statistic is in the rejection region, and in that case we reject the null hypothesis. Now this idea of a rejection region is something that follows on from the normal distribution. So what I'm going to do here first off is draw a little number line, or draw a number line here down the bottom corner, starting from 0. Okay. Now it's essentially part of the bell curve. So I'll draw this in as well. So the bell curve goes down like this here. Okay. Now what we have here is a rejection region, and it looks something like this. Okay. Now the size of the rejection region is alpha. Hang on a sec. Put that in red. Put that in white even. Is alpha divided by the number of tails. So I'm just going to call k the number of tails. So it's alpha or alpha over 1 or alpha over 2. And it's this rejection region here. And the size of the rejection region is alpha over 2. So this is the rejection region in white. Okay. Now, if the test statistic is in the rejection region, so this is the number line here. Okay. If the test statistic is in the rejection region, so if the test statistic is in the rejection region, for example, if it's here, then the p-value is we reject the null hypothesis. Now, what is the p-value in relation to the test statistic? So this here is the test. I'll put that in pink or magenta. So this here is the location of the test statistic on the number line. Here, that's probably a bit easier to read. Now, the region beyond the test statistic is this here, and the size of it can be expressed as a probability, and that probability is the p-value. So it has a important relationship with the test statistic. The p-value is the probability of being greater than or equal to the test statistic. Now, just recall that the test statistic is a z random variable, so we could actually write it as this. P-value is the probability of z being greater than equal to the test statistic. So that's how everything pieces together. But we're going to take it in very simplistic terms. So if the p-value is less than or equal to alpha, that's the one key thing we have to remember. Things can get quite complicated. There's a lot of stuff going on there, test statistics and number of tails and rejection regions. This is the one key thing to remember, is this part here. Reject the null hypothesis if the p-value is less than or equal to alpha. So, okay. So there I have it done there. I have it done there for the right hand side, but we can do it here for the left hand side as well. Sorry, I'm going to run out of memory soon. So what we're going to do is, this is essentially, so here alpha is 10. Okay. Now, a lot depends on whether or not it is a one-tailed test or a two-tailed test. Okay, so let's just say, for argument's sake, this is a one-tailed test. Okay, and that what we have here is the rejection region. So what I have here is the rejection region. And again, this is the test statistic down here. Test statistic is 1.46. Now, the critical value is this. This is the critical value here. It is minus 1.28. But that's really, those two terms are not really relevant here. What I'm interested in is the probability of being beyond the test statistic. And that, in that case, what we have here is this white region here. I'll put it in white. Blue just not working. So this white region here is the probability of being beyond the test statistic on the number line, and it is smaller than alpha. So it is in the rejection region. Just to give you a counter example, suppose the test statistic was here in the number line, it would not be in the rejection region. We fail to reject on if it was on the number line here. That's okay. So that's the lower tailed test, or using the p-value approach. The same can apply to the upper tail, and in this case the rejection region is 0.04. Again, there's no particular reason for that, but it just is. And the p-value is 0.04. And again, we reject the null hypothesis. Now, the one key thing here is that p-value, this is the key thing here, p-value is less than or equal to alpha, so we reject the null hypothesis. If whatever else you remember this part here. Okay, so small p-value, reject the null hypothesis. Okay.